Canada stands at a massive crossroads. Do we choose the stealth power of the F-35 or the industrial freedom of the Gripen's RM-16? One engine offers total NATO dominance, while the other grants us the keys to our own sovereignty. Is tactical superiority worth sacrificing our domestic manufacturing independence? Protecting the vast Arctic frontier requires more than just speed. It requires a jet engine we can actually control and maintain on our own soil. Can the RM-16's domestic autonomy outmatch the F-35's unmatched stealth in the world's harshest climate? We are breaking down which engine truly secures Canada. Most people think the F-35 is the ultimate choice for Canada, but the RM-16 engine might be the smarter long-term bet for our economy. We are pitting the Joint Strike Fighter's global logistics against the power of domestic manufacturing rights. Is interoperability with our allies more important than owning the technology? By 2026, Canada's defense planning isn't being driven by ideology, it's being driven by geography. The High North is no longer a frozen buffer, it's becoming an active strategic corridor. Melting sea routes, expanding patrol zones, and increased great power presence are forcing Ottawa to confront a hard reality. Sovereignty in the Arctic isn't declared, it's sustained through presence, and presence depends on propulsion. Long-range patrols over the Canadian North demand something very specific from an engine. Not just raw thrust, but endurance. Not just speed, but reliability in extreme cold. Aircraft must launch from isolated forward operating locations where infrastructure is minimal, temperatures plunge below -40, and maintenance windows are brutally limited. This is where the propulsion philosophies behind the F-35 and the Gripen begin to diverge sharply. The F-35's F-135 engine was built around one central priority: stealth-enabled dominance in high-end conflict. It delivers immense power, but that performance comes with a tightly integrated, high-maintenance ecosystem. Sustainment often depends on specialized tooling, controlled environments, and a deep logistics chain, conditions that align more naturally with established air bases than remote Arctic strips. The RM-16, by contrast, reflects a different design mindset. It leans toward rugged operability, emphasizing modularity and field-level serviceability. In practical terms, that means an engine architecture intended to be swapped, serviced, or stabilized without the need for a full industrial support footprint. And in the Arctic, that difference isn't theoretical. Operating advanced jet engines in sub-zero environments introduces challenges that go far beyond flight performance. Lubricants thicken, metal tolerances shift, electronics contract. Cold-soaked systems can delay scramble times if engines require extensive conditioning before ignition. At Canada's forward operating locations, places defined by isolation, weather volatility, and limited ground crews, propulsion isn't just about capability in the air, it's about survivability on the ground. Because in the High North, the engine that can launch reliably from the cold may matter more than the one that performs best in perfect conditions.
If the Arctic defines the mission, the engine defines the outcome. The RM-16 isn't being positioned as a traditional fourth-generation power plant. Its updated 2026 architecture reflects a clear objective: narrow the performance gap that has long separated lightweight fighters from fifth-generation platforms. At the center of that effort is thrust efficiency. The RM-16's improved thrust-to-weight ratio isn't just about producing more power, it's about producing usable power without dragging the aircraft into fuel-heavy operating cycles. That matters in Canada, where patrol distances are measured in thousands of kilometers, not quick reaction hops between dense air bases. Instead of chasing maximum thrust alone, the engineering approach appears focused on sustained performance, maintaining speed, climb, and endurance without pushing the aircraft into constant afterburner use. In practical terms, this is how a smaller airframe begins to operate in the same strategic envelope as heavier stealth fighters. But the gamble isn't purely technical. There's also an industrial layer shaping the debate. The Swedish Aerospace consortium behind the RM-16 proposal has tied its offering to a Made in Canada framework, promising localized assembly, technology transfer, and long-term sustainment roles within Canada's own defense industry. That shifts propulsion from being just a performance decision to becoming an economic one. Domestic manufacturing doesn't simply create jobs, it reshapes control over maintenance cycles, upgrade timelines, and software integration. areas that traditionally remain locked within foreign supply chains. And then there's supercruise. The RM-16's ability to sustain supersonic flight without relying on afterburners directly impacts how Canada patrols its vast northern approaches. Afterburners consume fuel at a rate that limits range, a critical vulnerability when operating over sparsely supported Arctic regions. Supercruise changes that equation. Maintaining high-speed intercept capability without excessive fuel burn allows aircraft to respond faster, stay on station longer, and return without relying on forward refueling infrastructure. In Canada's context, that's not just a performance advantage, it's an operational multiplier.
For all the discussion around alternatives, the benchmark Canada is measuring against already exists. The Pratt & Whitney F-135 remains the most powerful fighter engine currently in operational service, delivering roughly 43,000 pounds of thrust. That raw output isn't just about speed. It underpins the F-35's ability to carry heavy sensor loads, maintain stealth performance, and operate across multiple mission profiles without compromising survivability. And in 2026, the story doesn't stop at baseline capability. The Engine Core Upgrade, or ECU, is designed to improve thermal management, durability, and power generation, three areas increasingly tied to modern combat aviation. As fighters become flying data nodes rather than just intercept platforms, engines are now expected to support advanced avionics, electronic warfare systems, and future upgrades that demand more onboard energy. In that context, the F-135 isn't just propulsion, it's infrastructure. There's also a strategic layer tied directly to NORAD integration. Because the F-35 operates across the United States and Allied fleets, engine commonality simplifies cross-border sustainment. Shared parts pools, standardized maintenance procedures, and integrated logistics chains reduce the friction of operating in joint defense frameworks. For Canada, whose northern defense posture is deeply intertwined with U.S. coordination, that interoperability carries operational value. It means an aircraft grounded in Alaska or Nunavut could, in theory, draw on the same sustainment ecosystem supporting U.S. assets. Then comes the financial reality. Canada has already committed significant investment into the F-35 program, from acquisition planning to training pipelines and infrastructure alignment. Pivoting towards a domestically supported propulsion model introduces not just opportunity, but risk. A newer, less proven engine ecosystem may promise flexibility and sovereignty, but it also lacks the decades of operational maturity, testing depth, and allied integration that the F-135 now brings to the table. In strategic terms, the choice isn't simply about performance. It's about whether Canada values industrial independence enough to step away from a propulsion system already embedded within its continental defense architecture.
In fighter procurement, the real battle isn't fought in the sky. It's fought over decades of operating costs. On paper, both propulsion paths promise performance, but over time, hourly flight cost becomes the silent strategic pressure point. The RM-116's modular design is built around a simple premise: reduce downtime, reduce cost. Instead of deep depot-level servicing, the concept emphasizes faster component swaps and simplified maintenance cycles. For the Royal Canadian Air Force, that could translate into fewer grounded aircraft and a leaner operational budget, especially critical when patrol commitments stretch across massive northern distances. Lower maintenance intensity doesn't just save money, it preserves readiness. The F-35 takes a different route. Its sustainment model is tied to predictive maintenance systems, advanced diagnostic software designed to anticipate component wear before failure occurs. In theory, this minimizes unexpected breakdowns. In practice, however, it also creates dependence on the tightly networked logistics and data ecosystem. During a national security crisis, that distinction matters. An aircraft designed for rapid field-level intervention may recover faster from mechanical setbacks in remote locations, but a globally supported platform backed by predictive analytics may avoid failure altogether, assuming its support network remains uninterrupted. That brings the conversation to supply chains. The F-35 benefits from a vast, established global logistics system. Parts availability, standardized procedures, and allied interoperability create resilience through scale. A localized RM-116 production line offers a different kind of resilience: independence. Domestic manufacturing could reduce reliance on external approvals, shipping delays, or geopolitical bottlenecks. So the trade-off becomes clear: global reliability versus national control. And in long-term fleet readiness, that choice may shape how Canada balances sovereignty against stability.
So here's the real question Canada has to answer. And it's not which jet is better.
It's which propulsion philosophy survives the Arctic reality. Because in the North, the winner isn't the platform with the most hype. It's the one that can launch, intercept, recover, and repeat, day after day, from remote bases, in brutal cold, with limited crews and zero room for downtime. If Canada stays with the F-35 plus F-135 path, the payoff is obvious. You're buying into the most powerful engine ecosystem in the Western fighter world, paired with stealth, sensors, and an alliance-wide operational network that's already built. You get interoperability with the US, deep NORAD alignment, and a mature program that keeps evolving toward 2030. But the cost of that power is also clear. It's a high-dependency model, specialized sustainment, complex supply chain dynamics, and a long-term readiness question that isn't just about jets. It's about how easily Canada can control its own maintenance tempo in a crisis. Now pivot to the Gripen plus RM-16 proposition. This is not just about performance. It's about operational flexibility and national leverage. A modular, rugged, field-friendly engine philosophy is basically saying Canada doesn't need the most complex solution. Canada needs the most dependable solution. And the industrial promise matters too. Made in Canada isn't just an economic line, it's a strategic argument. If you can build, sustain, and upgrade more of the ecosystem at home, you reduce vulnerabilities that don't show up in brochure specs. Then there's the Arctic intercept math. Canada isn't defending a small airspace pocket, it's defending a continent-scale frontier. That's why concepts like efficient high-speed response and reliable cold start readiness become more important than pure top-end thrust. If your engine forces you into fuel-heavy operating cycles or long maintenance resets, you don't just lose money, you lose presence. What this means for 2030 and beyond. By 2030, Canada's defense posture will be shaped less by what it buys and more by what it can sustain. If Canada prioritizes global interoperability, the F-35 path strengthens the continental defense mesh with the US and allies. If Canada prioritizes specialized Arctic readiness plus industrial control, the RM-16 route pushes Canada toward a model where sovereignty is enforced through independent sustainment and faster readiness cycles. So the final verdict depends on what Canada believes sovereignty really means. Is sovereignty best achieved by being fully integrated into the strongest allied ecosystem, or is sovereignty best achieved by owning more of your propulsion, maintenance, and production chain, even if the platform isn't the biggest, loudest symbol of power? Now, I want your take. If you were advising Canada in 2026, would you choose F-35 power plus stealth plus NORAD integration, or Gripen RM-16 flexibility plus Arctic practicality plus domestic control? Drop your verdict in the comments. This is Skyjet Wings. Thanks for watching.